For today's demo, we are going to be using a network that is very similar to the following. We have an attacker on one side and a victim on the other side. The attacker's machine is running Kali Linux, a customized Linux distribution for pen testers. The victim machine is running Windows XP Service Pack 2. We purposefully chose a soft target for this demo, as the goal is to focus on the way in which the intrusion detection systems work, rather than on the specifics of the exploit. Besides the attacker and the victim, we have two different machines, each running a collection of network monitoring tools. The first is what we will refer to as our signature-based sensor, and it is running a default configuration of the Security Onion distribution. If you're not familiar with this distro, it is a customized version of Ubuntu that contains Snort, Suricata, Bro, OSSEC, Squeal, Squirt, Snorby, Elsa, Explico, Network Miner, and many other security tools. You can learn more at securityonion.net. During this demonstration, we are going to perform a series of network interactions based on common attack patterns. Specifically, we are going to utilize what is referred to as a drive-by attack, wherein an unsuspecting victim visits an otherwise legitimate website and is inadvertently compromised. In the first stage of this attack, the victim, in our case a user on our Windows XP machine, opens a browser and visits a website. Unbeknownst to him, the web page he visited was compromised and contains a hidden iframe. The iframe causes the victim's browser to reach out and make a web request for more content, which is, in our case, the exploit code hosted by the attacker. This causes the attacker's web server to deliver the exploit code, which then runs in the victim's browser. Since the victim's browser was vulnerable to the exploit that was delivered, it runs successfully and then causes the payload to run, which establishes a communication channel with a remote command and control server which is hosted by, or at least controlled by, the attacker. At this point, we'll switch to the lab environment and walk you through each of the machines. You can see the four machines as discussed previously listed here, as well as a fifth, Replay, which we'll introduce later. This first machine is our attacker, running Kali Linux. We have a command window open to our demo directory and a few of the scripts open in an editor so we can walk through exactly what is occurring. The second machine is our signature-based sensor running Security Onion. We'll go ahead and open up and log into Squeal so we can see the alerts as they come up. The fourth machine here is our Windows XP Service Pack 2 machine. Again, we understand that this is not a terribly interesting attack target, but we wanted to focus on the sensors in this demo and not the attacked machine. At this point, I'll switch over to the attacker and we'll set up for our first attack. You can see in this window that I'm running the Apache web server. This is hosting our compromised website. In many or most real-world scenarios, the compromised site would live someplace completely different and is often an unknowing participant in the attack, but for the sake of keeping our machine count a little constrained, we are going to host it on the attacker's machine. Here I've run MSF Console, one of the command line tools in the Metasploit framework, and provided it a script which is simply a list of commands that tell the application how I would like it configured. As you can see from the script, I am selecting the IE create object exploit, providing it an IP to be hosted on, the URI, the port, and some other basic settings. Additionally, here I'm setting the payload, or the code to be delivered by the attack, to the reverse HTTP interpreter shell. This is a full-featured, if not a little noisy, tool set for post-exploitation goodness. As you can see, the command is now run and it's all configured with these values. As you can see on the signature machine, there's no alerts, which is what we would expect because we haven't introduced anything on the network, no traffic or anything. On our victim, we're going to open our favorite browser, click the bookmark for our news site. As you can see, the page loads normally and the user suspects nothing. However, if we switch back to the attacker machine, we'll see that the exploit was requested, sent, ran successfully, and an interpreter session, or a command and control session, is now established between the victim and the attacker's machine. Looking at the signature tool, we see a number of alerts exactly as we would have expected, indicating that something bad just happened on our network. For reference, sometimes you'll see some yellow alerts, and those are often ignored as noise. However, the orange and red alerts we see here would definitely draw the SysOp's attention. At this point, we have simply confirmed that things are operating as we expect them to. A victim visited a compromised site, downloaded an exploit, the browser fell to the exploit, and both of the sensors flagged the activity as malicious. This is no surprise. The purpose of this step was to establish a baseline and confirm that everything is, in fact, working as we expect. This flowchart, similar to what we looked at previously, restates what we just saw. At this point, we have reset our environment and cleaned up the signs of the previous attack. You can see that the XP machine is happy again, and there are no nefarious processes running. We've checked the list here. There's nothing there. We switch over to our signature machine. You can see that there are no alerts there. And we're going to run the same command as we did before with a slightly different script passed to it. So I'm going to go ahead and start that, and we'll look at the script here and talk through it. So you can see from the script, it's almost identical to the previous set of commands. We're using the same exploit, the same host and attack IPs. There are, however, three really important differences. The first is that I've decided to change the port for hosting my attack and enabled an SSL. You can see that on these two lines, and then you can see I'm using a certificate there. The second is that I've added an S to this line. So instead of using the reverse HTTP interpreter shell, I'm using the reverse HTTPS interpreter shell. And finally, I've added the enable stage encoding equals true flag. This means that the Metasploit engine is going to encode or scramble the payload a little bit to make it look different as it traverses the network, and then also build into the payload the super secret magic decoder ring so that it can unscramble itself on the other side. And I know you've been looking at this and thinking, wow, those are pretty impressive hacking skills. But in reality, they aren't. Everything we've looked at so far is available to anyone in a Metasploit 101 course. There's nothing special about what we're doing. Now let's take a few minutes and see what effects our changes have made. Confirming as you would expect that here on the signature machine, there's no alerts. We've not introduced any traffic again, just like the last time. Back on our victim machine, just like before, we're going to open up Internet Explorer and view the news. The only difference is that we're going to use a different bookmark to hit the page, and this is set up for the sake of the demo. The only real difference between these two bookmarks is that the second one is hitting a page that has the HTTPS version of my malicious iframe embedded into it rather than the HTTP version of the hidden iframe. Otherwise, they're completely identical. Once again, the page loads normally, and the user has no idea that anything has happened. Everything seems fine. He's reading the news. Life is great. However, back on the attacker, you see that the reverse handler was set up, but you see here the payload was requested, it was sent, and a communication channel has once again been established between the two machines, the interpreter shell. Now on the signature machine, unfortunately, we don't see any alerts here. According to the signature sensor, nothing has happened in our network that we should be concerned about. Everything's fine. We're all happy. The thing we want to emphasize at this point is that the differences between the two attacks are very minor. Anyone with even a cursory reading of the documentation would experiment with these settings. Yet, since the resulting exploit did not exactly match a pattern previously documented in the signature sensor's library, it didn't trigger an alert. Okay, to emphasize the point a little bit further, let's utilize our communication channel and gather some information from our victim. So I'm going to type sessions tech I1. This command tells Metasploit that I want to interact with the victim connected to session 1. Now I have, similar to before, sent a series of commands to this session. While the script is running, we'll look at the command script and discuss what it is doing. The first thing I'm doing is migrating to a different process in the victim. I'm attempting to hide myself a little. The default settings will cause my attack to show up in the process list as notepad.exe rather than some oddly named process. The next step, I try to elevate rights and get administrative or system privileges. Then I run a check to see what permissions I have. Then I run a call to see, am I running on a VM or not? I do the get countermeasures call. I collect a number of things like running a credential collector. You see that scrolling through the background. And then we're going to enumerate shares, check to see if SNMP is there, USB history. You see that's running right now. And you can see some of the most recent USB devices that were connected. I'm then seeing if I can enumerate any of the Microsoft product keys, which you see is there. Then here at the end, I do a search across the target machine to see if anywhere on that machine there's a file called password.xls. I've hard-coded where I know I'm going to find it. You can see it finds it up here. And then I download the file across the network to my machine and I background my session. Again, nothing special here. It's a simple smash and grab of info on the machine using the built-in scripts. We can see that the operation's finished. Let's check our sensors now. On our signature machine, we still have no alerts. This really isn't surprising as it didn't fire on the initial exploit, and likely now just sees it as an SSL tunnel between consenting systems.